Hey y'all, welcome back to another installment of this three-part series on the negative lead, positive lead, and the safety box. I want to welcome back both of my subscribers. I want to let you know that I do read all the comments and I really appreciate all the feedback, advice, suggestions. Know that I can't possibly implement them all, and I am starting off by pursuing the KISS principle, keep it simple, stupid, and trying to do this in a simple manner. Will it work? I don't know. Is that the safest way to go about it? We'll find out. Anyway, in the last episode, we made this handsome T, which combines two negative leads from our two battery packs into one and runs to our safety box. So you may be asking yourself, well, why do we need a second video? Why do we need to dedicate our time to making a positive lead, and why can't we just knock out one just like it and call it a day? And as Vice Grip would say, enjoy a cold snack. Well, for that, we have to take a deeper dive into the safety box and do a little review and find out exactly why the positive connection is a bit different than the negative connection. So here we go. All right, guys, so grab your brew and let's review. We're going to go quickly through this. I know that some of you have written me and said you absolutely love the longer formats of these videos. I've gone from 15-minute videos to 30-minute, now just under an hour, and you were begging me for longer content and to drag these out even more. Unfortunately, I can't do that, so I'm going to try to keep this short and sweet. Hopefully, we can wrap it up in under an hour. Here we go. So we have this long OEM lead that comes off of our module number 1 negative and runs to the safety box negative input. And then we have a shorter OEM lead that runs from the number 6 OEM module to the positive input of the safety box. Notice here I have two safety boxes, and because I have two BMW 530e hybrid battery packs. So each 6 modules belong to a safety box. So we also learned in a prior video that these are not direct connections, and we're going through these orange switches, which are called contactors, essentially fancy name for heavy duty relays, if you will. In our current safety box, the Gen 2, BMW bumped up the rating on these to 175 amps. Okay, so this is what we have. Well, this is not exactly the full story here, okay? And the leads differ. So in the past, I've been telling you, hey, this is what lives in a safety box, and I was showing you things like the contactors and the guts. Well, why don't I just open up a safety box and tell you why I've been just showing the components that are inside of it? So here we go. This is an unopened contactor box. First thing we need to do is cut these labels that explicitly tell us not to cut these labels. I've already done that with a razor blade. So then you take one of your nicer butter knives, and I found this is the best way to do it. This part is safe because there are no capacitors in this safety box. Notice our orange leads are completely disconnected. So we can just go like so, and this pops up. And it is a cluster. This is a German engineering marvel, okay? There is a ton of stuff compacted into tight space. You can barely make out the orange contactors there, and that's why I've been just showing you the components that are in there. Again, I invite you to go back and look at me taking apart these safety boxes, both the Gen 1 and the Gen 2 in prior videos, especially if you suffer from insomnia. Anyway, so we have this contactor box, and I'm going to, just to make it easier to demonstrate, okay, here I have one that I ripped into smithereens. And what you will see right away is that now we have a new component here, which is a fuse. This is a PEC 350 amp fuse. BMW did not change these fuses. It was 350 amps, and what does that say? 450 volts in Gen 1 and then also in Gen 2. Now, when I'm talking about these generations of this BMW hybrid vehicles, for the most part, they were from 2017 up till June of 2019. Then BMW, I think, did a mid-year upgrade. And in July of 2019, they started making the 12 kilowatt hour battery packs. If you are on the fence about getting one of these, if you're thinking about it, I would say hold out for the newer 12 kilowatt hour modules. If you're unsure which one you're getting, although I'll try to post on the screen how you can just look at the label and it will tell you if they're 9 kilowatt hours or 12 kilowatt hours. To play it safe, look for 2020 and newer BMWs as the donor cars, and you should be safe. All those should have the 12 kilowatt hour, larger capacity battery pack, same physical size. Okay, so as you can tell, it's impossible to see in this assembled safety box this fuse, right? It lives right in front here. But because I have one here to demonstrate, it goes right in there, and it lives in front of our positive contactor, hence the difference. There is no fuse on the negative lead. There is one on the positive lead. I think that might just be a cost-saving move by BMW. You could easily fuse the negative side as well if you choose to. It's not going to harm anything. Now, in the spirit of full disclosure, when we talked about the negative lead, there is a component that sits in front of that contactor as well. So the negative lead goes to what we call a negative contactor. Positive lead goes to what we call a positive contactor. Sometimes this one is referred to as a main contactor. These are just names. These are exact same pieces of equipment. We can interchange them. You can, if you take your safety box apart and you forget which one is which, it totally doesn't matter. It's just what we call them. They are exact same thing. Okay, so what sat in front of the negative contactor was a current shunt, a current sensor. Now, it wasn't this particular one. This is just so that we can use it as a symbolic representation here. It sits in front of the contactor and it senses not only current but also voltage, and it can, I think, pick up voltage from 3 different spots. So like volts in the battery pack before the contactor, and then what's coming out of the safety box on the other side. I didn't talk about this because this is not a control mechanism. Unlike a fuse, this will not blow. Unlike a contactor that opens and closes, this does not control the flow of energy. And honestly, I just forgot. I just didn't remember to mention this, and I didn't want to complicate things too much. But in the spirit of full disclosure, that sits on the negative lead, okay, inside the box. Then we have the fuse on the positive lead. And let me show you what this actually looks like. So when it comes to these current shunts, this is what I would call a standalone current shunt, ISA. I'm not even going to try to pronounce the long name. I'll post it on the screen here. And this one here is what I call an integrated current shunt because it's integrated into this circuit board, okay? And it's a sophisticated piece of equipment. It's CAN operated, but they both do the same thing. There's other versions of current sensors, Hall effect, which are like ring, and the cable passes through them. And so it's like if I make a ring out of my, like that, passes through it, and it doesn't make contact. It just senses the current that goes through it. It's very similar to, the Hall effect sensor is very similar to, I'm going to try to show this on the white background, to a multimeter that has this clamp style. So the way I would sense the current in this cable is just clamp it on like that. So I believe I recently learned that the Nissan Leaf safety box, contactor box, has a Hall effect, the ring type current sensor. Neither here or there, I'm just sprinkling in more information. Okay, so because we have to incorporate a fuse on the positive lead, that setup will take a different form. Similar to the negative, but we will have to incorporate not one but two fuses, because I want to dedicate one fuse to protect one battery pack and a second one to protect the other. I decided that before I put away these contactors, I'm going to show you how they sit inside of this safety box. So if we were to remove the circuit board on top there, this is how they sit inside there, okay? So I believe one faces away from the front, one faces towards the front. That really doesn't matter, it's just how they're in here. And then the fuse is in here, okay? And then we put this front piece on. Yeah, maybe it's too busy to kind of describe to you how the bus bars run. I'll post some pictures of that. You don't have to geek out that much. I'm just showing you kind of the guts of it and how incredibly cleverly designed this is, with everything fitting in there. And this is not even half of the guts that are in there, okay? Again, there's going to be a third video on the safety box itself, but here you can see this white piece of bar soap. That's a resistor, so that sits in there. There's an actual relay, which maybe it's still called a contactor, but this is a high voltage, low current relay that's part of the pre-charge circuit. Of course, we have the circuit board, ton of wiring, cabling, what have yous, right? Pretty impressive piece of apparatus. All right, let me put this away and let me show you how I plan on building the positive lead. Okay, so if these are my two positive leads coming off the battery pack, each one of them is going to get a fuse. Now, these are the OEM fuses. And I went out and I purchased some 250 amp fuses. I'm sort of going to downgrade the fuses that protect each battery pack, but I'll keep a 350 amp fuse still in the safety box. Let me know if you agree with this idea or not. So I scored these 250 amp fuses. These are really nice Busman fuses made in the USA. 250 amps, 500 volts. So thank you, Arthur, for turning me on to these. So I'm thinking about using for testing, proof of concept, and maybe even for long term, using these or this brand, but in 250 amps. Am I making a mistake in replacing the 350 amp fuses with 250 amp? I don't know. I think I've seen this battery pack push 500 amps. I'll show you a video of doing some test drives and test pulls with Arthur and his Jaguar. He has, I believe it's a 96 Jaguar XJR. I don't know my Jags. He has a beautiful conversion. Proud owner. Arthur, how long did this conversion take? Couple weekends?
A little bit more than that.
How long, seriously?
Well, close to a year, I would say, to get it like fully working, roadworthy. A few months more to perfect a couple of things.
We're gonna do more videos of this whole engine bay. Throw it up on the lift, go under it, check it all out. It looks so freaking OEM. It's the only way I can describe it. And we deliberately did some pulls. And you know, when you're cruising along, you're pulling like 40 amps, 50 amps. All right, guys, we're on the freeway and we're gonna just pull 60 at 65 miles an hour, and I'll show you some of the gauges here. So are we at 65?
Yes, we are.
So below 100 amps going 65, we're at 84 amps. Steady right now?
Yes.
So down to 60 amps going 65 miles an hour?
Yes.
Out of this pack. He has the exact same modules. He has the same Lexus GS450H transmission. He has the same inverter. He has the same charger and the DC-DC converter as I do. And so it's pretty good apples to apples comparison. I don't know how much the vehicles differ on weight, but when we did some test pulls, I've seen 200 amps being pulled quite frequently when like accelerating on a freeway on-ramp. And then one or two times he gunned it for me and I watched it, and I think the amps just bleeped at 500 amps. All right, guys, here we're doing the max pull. So it's 500 amps, and we're just pulling uphill right now. How fast are we going?
75.
So we got up to 75, and we pulled up a hill. We're going to get to the specs and how certain things are rated, things like fuses, okay? Just because this says 350 amps on here, this doesn't mean this is the max this fuse can do. Same with contactors, you know, because it would make you wonder, how did 175 amp contactors survive something like 200 amp pulls, things like that. So they have their, what I call all day rating. That's what is usually written on them. And then they have what I call, you know, their like max. So if we use the analogy of a weightlifter, right? You ask somebody, hey, how much do you bench, right? And they'll say like, oh, I bench 350 pounds and I can do that all day long. You're like, okay, great. Now, can you do more than that? And they'll say like, yeah, man, I can do 500 pounds for 30 seconds. So that's kind of how electronics are rated. That's a new concept to me also. I'm trying to comprehend that and wrap my mind around it, because when you're familiar with like the automotive fuses, let's say, you know, if it says 2 amps, that thing will blow when it hits 2 amps. Then when you get to like 5, 10 amp fuses, same thing, it gets a little bit over that. There might be a slight margin, and that thing's gonna pop. Anyway, so I'm going to put these aside, these 350 amp ones, and start playing and demonstrating with these 250 amp. Okay, so yeah, let me know if it makes sense to downgrade the fuse for protection of each pack from the 350 amps to 250, because now the load is going to be shared across 2 packs. So the idea here is, once again, we're going to cut off the ends. We're going to put ring terminals on each one of the ends. Then I'm going to take 2 of these fuses like so and make a T out of these. So each one of these ends will go into the fuse. Fuses are going to be joined together with a T coming out, and then this end will plug into the safety box, where it will go through a third fuse, okay? That's just how it's going to be. We'll see how that works, okay? Where will these fuses live? Well, I started out with the same idea. You know, I went to my trusty Home Depot and I bought one of those T-type housings. So I bought one of these T-type housings, and they had 2 sizes. They had the 3/4 inch, and I believe this is like a 1 inch. And unfortunately, these don't fit. On their website, they show that they make larger, let's say 1 3/4 opening, maybe 1.5 inch opening, maybe 2 inch opening. So I think we could buy a bigger housing, ordered online, and then width-wise these would fit, but I'm not sure this would be long enough, okay? If we look at it maybe this way, it's not really long enough, right? So then I went to plan B and I jumped on Amazon. Let me show you what I found there. So I bought a box, plastic box, and has no openings in it anywhere. but I'm going to drill holes in it. And then now I'll get to use these screwy type cable clamps. Some of you were suggesting I use those on my type T connections, which is really hard to do just because how long these kind of leads are. They're too wide, but it makes sense to do that on this box. So I'm going to drill some holes. I'm going to insert these in, and the way this is also going to make a T, and then inside there, this is the general idea. Okay, I'll have the fuses sitting like that. The two leads coming in from both sides are right here, and then the main one coming out of the middle here to go to the safety box. So I think we're going to be looking at something to this effect right there, right? All right, let me build some cables and get back at you all. Okay, so just like when we did our negative leads, we marked them with black heat shrink to just signify negative. I am slipping on these this red heat shrink on these leads just to help me at a glance be able to quickly tell these are positive leads. So I'm going to do that. I'm going to apply some heat to these, and then I'm going to have to put on those ring terminals. So again, I have 6 of these to put on because each one of these is 2. Again, I'm not going to bore you with that. We'll just skip ahead in the video and keep things moving. So here we go. All right, guys, great news. I may have finally found the use for the hardware from these 2 battery packs. That's right. We have some nuts and bolts to use on our fuse connections here. Now, before you go raining on my parade, yes, these are nylon locking nuts. Yes, they are going to melt due to the volcanic lava-like heat from these cables and these fuses, and I shouldn't use them because they'll loosen up and come apart and I'll blow everything up. And yes, I'm still going to use them for now. Draft, prototype, we're just testing. Okay, so yes, I am happy to be able to use them. So I also decided that I'm going to test with these cheap, inexpensive 250 amp fuses instead of the OEM ones. I'm going to save those for later, and hopefully my orange 250 amp fuses will come in the mail. I'm sure the day after the video they'll arrive. Anyway, here is the plan. I'm going to take this combined pack apart, spread it out into 2 packs, flatten it out, flip the upside down one right side up, and I'm going to use some more orange cables to link all the modules up, bringing up the voltage from negligible to a bad hair day. And then I'm going to take their temperature. In other words, I'm going to check the pressure or the voltage of each pack. We're hoping to be spot on, if not 1, maybe 2-ish volts per pack off, and then that will allow us to link it. So let me flatten them out, let me connect them, and I'll be back. Okay guys, so I have the 2 packs in front of me. They are all linked up now. Now they are dangerous, so let's remind ourselves of rule number 1 of EV conversions, which is don't get dead. Okay, at this point, I'm going to use my multimeter here to measure each pack's combined voltage, if you will, or total voltage. So I put this on the volt reading, DC voltage that is, and now following some of Damien's advice, what we don't want to do is we don't want to hold these leads with 2 hands and touch one to the negative, one to the positive, like you would do normally with low voltage electronics. So it's going to be probably hard to show you the reading, but The one negative, I'm going to use the negative lead. If you mix up the leads, it's just going to read negative number. So one-handed, just wedge it under here. And then with my other hand, I'm just going to wedge it under the other lead. And what I'm seeing here is 346.3 volts, okay? So remember that. That's the red pack. It's reading 346.3. So disconnect them one hand at a time. All right. Now over to the green pack. Second verse, same as the first. Let's set this down here. First, I'm going to, on number 1, I'm just going to wedge this under here. And then I'm going to take with one hand the other lead on the positive, and I'm going to wedge it under there. And we're getting 345.1. That's, that's good enough for the girls I date. All right, good enough. We're going to now try to link him up together. I'm going to start with the negative cable. So let me disconnect this. Turn it off. Okay, rubber mat. Should say heavy rubber mat. Here is our long negative lead. And we're back to that mirror image or symmetry. So on both of these packs, the number 1s where the negative comes off of are on the outside. We really don't need to connect the safety box at this juncture. All we want to do is what I'm calling the poor man's balancing, okay? This is not recommended. Don't go doing this. This is just something I'm attempting here, okay? So let's see here. We're going to connect negative of the red pack to the negative of the green pack. Okay. Should probably stand on one leg while I do this. Okay. So our negatives are connected. We don't have to connect this to the safety box for this experiment because it would just connect to an open contactor and not pass the current out of the safety box. And even if it was to pass it out of the safety box, it's like, so what? It has nowhere to go right now. Okay, so now I'm going to take the positive lead, and the connection there is going to be a little bit different. So let me prep for it. All right, guys, so I made this setup here just for safety. It's just a piece of wood with one of the fuses zip tied to it. The other end is not plugged in at the moment, okay? The point is that I don't want to be holding anything with my hands as I touch the two fuses together. That's going to be the extent of our video today, is to see if we can parallel two packs without blowing ourselves up, without causing any sparks or black smoke, whatever. One thing I want to point out is that I will be using proper safety equipment here in the form of these plastic pliers, which I've owned for a while now. I attempted to use them once, and the one time that I tried to use them, I broke one of these orange connectors. Now this one isn't broken. I can't find the broken one, but this clip underneath there, that is what I broke. That's what this little piece is here. And the one time I use the pliers, the safety tool, I break the connection. You've seen me using this random wooden stick to disconnect these a dozen times. The stick works fine. So the moral of the story is, again, just use your common sense. Okay, so when making these connections, let me share a top tip with you. We don't want to join these fuses and then go connecting the leads to the battery pack. And the reason for that is in case of arcing or welding or any type of silliness, we don't want to use the cables, but more importantly, the modules, okay? We can buy more cables. They're like $70 or less, depending on the cable. The modules are really expensive now. I doubt you can find them individually. If you could, they're probably like upwards of $300 each. So I inadvertently made a bad connection once last year or 2 years ago, and I'll show you pictures of what a buzzed and arced connection looks like. So we want to avoid that. So if anything, connect the leads first and then join them wherever you're going to join them. Then that way we'll either arc here on the fuse, or we'll ruin the fuse or something like that, or nothing will happen. But we don't want to join our fuses together. Again, both of these leads, the positive leads, are still disconnected. We don't want to bolt these up like this and then go connecting them to the positive leads on the modules, is what I'm saying. Okay, so I have to be more safe than visual here, okay? So you can't really see exactly what I'm doing, but it's really not a secret. I'm just going to connect this positive lead to the positive terminal right here on number 6, okay? That's what I'm doing here, one-handed behind this board. Okay, so now if we were to measure from this fuse to the negative lead, we would read the voltage of half the pack, okay? Now what we need to do is now we need to connect the positive lead to this other module, all right? So, I can hold it with these pliers here. I'm actually going to probably set it down. Let me go around this table. Okay, so I could set it down on a piece of wood. This countertop is just wooden, right? So if I do that, let's see what's the best way to do this. Still don't want to be touching it with 2 hands, and I don't want it to touch anything else. So let me get it in there. Okay. Okay. So now both of these leads are hot. All right, so here with plastic pliers with one hand, I'm holding this connection. Again, I don't recommend you do this, okay? I didn't know joining 2 packs was going to be so involved, but now we're going to touch positive to positive, okay? So they're making contact. No arcing, no sparking, no smoke. We just did a Poorman's balancing of 2 packs. So there's really 3 ways to put these in parallel. This is the worst way to do it, okay? Okay, just disconnected it, okay, so I can talk to you guys. So the worst way to do it, I'm learning, is pack to pack, okay? The bit better way, I guess, it will be module to module. The reason I'm not going that route, because it's a bitch with these proprietary connectors. It's a lot of cutting, a lot of splicing. These modules really don't lend themselves to that. And the third way, and which is the best way, and it's hard to argue with that because this is how BMW does it themselves. So in addition to the cars we've been talking about as far as donors, okay, there's the 330e, second gen of that, has 6 modules. 530e, both the first gen and the second gen have 6 modules. The 740e, first gen, second gen, have these modules. I'm not really familiar with the 740, but I think it's very similar to the 530e. So there's the first gen, second gen, they have 6 modules. Then there's the BMW X5, the white Rhino. That one in Gen 1 has only 6 modules. I think it uses the 9 kilowatt hour ones. But then it goes to 12 modules and 24 kilowatt hour battery pack in its second gen, okay? We can make some comparisons, but we also need to make some distinctions, okay? Those modules are different. They physically look the same, and there's 12 of them, so they still add up to 24 killer whale hours, I should say. But the cells inside of each module are welded together differently. So instead of being what is called 16S1P, 16S1P just means 16 cells in series, okay? What BMW does in the second gen X5 SUV is they put them 8S2P. So 8 cells in series and in pairs, or in those 8 in parallel with another 8 within the module. So you can't interchange the BMSs between these, because the slave BMS boards on these modules are configured for 16S. And you hear these terms thrown around. We're really getting deep in the weeds. But the X5 has 8S, so it uses different BMS modules. I think what it's doing is very similar to what Nissan Leaf does, where it has, I think it's 2 or 4 in parallel in each one of those sardine cans. I don't want to misspeak. I know what I'm thinking, I just can't get it out. All right, having done that proof of concept successfully, now it's time to build our box. And in order to finish this project up, I need to drill the holes for these cable glands. So I need one on either side here and one in the front for the T. So I'm going to go ahead and cut those holes out and then come back and we'll take a look at what the finished product looks like. So I had to switch over to this step 'em up bit, and I think I'm gonna mark how far deeper this needs to go. It's really hard to see for me, so I think once this red one disappears, we're good. Seriously. I colored the right one. I'm using this straight edge because this kind of has a ridge on it. See if we got lucky. It's tight, but I think I'd rather want it like this than too loose. Maybe I'll take a file to it. I don't know, let's see. Is that all the way in? Okay, it's kind of fighting it, so let's keep going. Wow. Gentlemen, that is almost on center. I love it. Nice. So here's the other end. Perfect fit. I'm impressed myself, actually. This This is too good for good enough garage, folks. I'm not sure if I'll be able to use it. All right, guys, so here I am starting to put together the box. I've made the long leads from the pack to the box, and I still have to heat shrink the one that comes out of this T into the safety box, but that's all right. We're gonna see what we can do so far. So I'm gonna loosen these up. And oh boy, okay, came off. Okay, so that's gonna be the general idea. We feed it through, and then we have to push this guy through there. Let's see, this will work. Loosen this up. Hopefully it will go through there. I really don't know yet how far it has to go in. It's gonna take a little finagling. I'm gonna try I like these fuses better because just this part is thinner. It's a dumb reason, but it is what it is. So I'm gonna feed that through. Back to building those ships in the bottle. Okay. There's a dot in the middle there. It's probably hard to see, but that's what I'm trying to center this on. This shows me how far I need to slide this guy on there. Which is oh, of course, forgot one of these. Surprise. It's not easy, fellas. Especially when you're in the video making business. Okay, so that goes on there. And again, as I said before, for all the attorneys salivating here, ready to sue me, this is not how to do it. This is just how I'm doing it, and I'm an idiot, so don't do this. Okay. So now, we're pretty close. I think that's expanding, is it? So, wow, still a ways to go to get that on there. Yeah. Well, you're getting the general idea of what I'm trying to accomplish here. Anyway, I'm gonna fight it and come back. Okay, guys, here it is. I muddled through it. I may be replacing these fuses still. I haven't decided which ones I'm going with. These are the OEM 350 amp ones. And really the hardest part of making this box was getting these cable tightener thingies on. I still haven't managed to get these two slipped on there yet. I'll do that. This one went on, so I have to finish it. And this is what it's going to look like. Pretty simple, pretty basic solution. These just screw in. They should be watertight. And hopefully this will work. We shall see. Thanks for watching, guys. The safety box video is up next.